Okay, welcome to this video on trinomial factoring. This is the second in a series of 4 videos about factoring, and this one talks specifically about factoring trinomials. Trinomial is just an expression in which we have 3 terms where the terms are separated by addition or subtraction. We're going to basically learn how to factor that into two different factors that each have only 2 terms. Okay, so this video will talk just about the case where the first coefficient is a 1. In other words, the thing starts with, the trinomial starts with x squared, not with something like 2x squared or negative 3x squared. So something like this, x squared plus x minus 6. And you can show that this can be factored into x minus 2, that quantity, that binomial, times another binomial, x plus 3. Just to kind of see that that's true, what I'd like to do is to just work it backwards. Let's take the answer, and if we distribute, we should be able to multiply every piece in one factor by every piece in the other factor, and show that that is in fact equal to x squared plus x minus 6. So let's do that. Everything in this side, the x plus 3, we would have to multiply by x first. So we would get x times x, which is x squared, plus x times 3, so plus 3x. And then we multiply everything on the right by the negative 2. So you have negative 2 times x, and then negative 2 times 3, which is negative 6. And then you can combine those like terms. You have x squared, positive 3x's minus 2x's leaves 1x minus 6, and that actually is the same that we started with, x squared plus x minus 6. Okay, so the process that we call trinomial factoring is basically to try to figure out what these two numbers are. Right? The factors always begin with an x and an x here, and our job is to find the two numbers that need to go there. Okay, and we're going to learn a procedure for doing that when the leading term is a 1. Okay, so let me jump right in. There are a lot of different procedures for this. If you search on the internet, you might find other ways to do this. At Desert Vista, we kind of favor this method because it's very flexible, and just with some extensions, which we'll talk about in the next video, it works even if the leading term isn't a 1. Okay, but we'll stick with the terms where we start with just x squared here. So here's the procedure kind of in shorthand on the right-hand side. What we're going to basically do is we're going to start by making a t-chart. Just like that, 2 columns, okay? I'm going to put an M at the top on the left and an A on the top at the right, and that stands for multiply and add, okay? So first we're going to determine whether the two numbers we're looking for are positive or negative. Now, the way I'm going to think about this is if you think about this in the form ax squared plus bx plus c, kind of the traditional thing for quadratics when you did quadratic formula, things like that. There's an implied 1 here, that's a. There's a 1 here, so there's 1 for b, and then c is the negative 6. So I'm going to look at the number a times c. In this case, that's 1 times negative 6, and that's a negative 6. Now, if that's a negative, the two numbers I'm looking for are going to have to produce a negative if they multiply together. And so that means that 1 is going to be positive and 1 is going to be negative. Okay? So that gives me something to shoot for when I'm looking for the two numbers. I know one of them is positive and I know one of them is negative. Now, the two numbers also must multiply to give me that negative 6. So at the top of my t-chart, I like to put that below the m, m for multiply and negative 6 to remind me that the two numbers must multiply to negative 6. Okay, so they always multiply to the two outside numbers multiplied. Okay, those same two numbers have to add to the middle number, the coefficient of the middle term, which in this case is a positive 1. Okay, so I've got a t-chart here to help me figure it out, and what I'm going to do is list pairs of numbers, starting with the left column. I want to list all the pairs of numbers, pairs of integers, which multiply to give me negative 6. One possibility would be a positive 1 times a negative 6. I could also have a negative 1 times a positive 6. Or I could have 2 times negative 3, or negative 2 times positive 3. And I think that's all the combinations of two integers that multiply to negative 6. All right, so then what I'm going to do is I'm going to add across each row. 1 plus negative 6 is negative 5. Negative 1 plus 6 is positive 5. 2 plus negative 3 is negative 1. Negative 2 plus 3 is positive 1. And then I look and say, okay, I need the two answers to the two numbers to add to positive 1. That's this last row, and that means the numbers on the left, the negative 2 and the 3, those are the two numbers that go in the factors. So then I can write out the two factors. I always put an x here, and then I would put an x here, and then I fill in the two numbers. So I'm going to fill in a negative 2 and a positive 3. And that's all there is to the procedure right there. That's how we find the two numbers. Now, we should always finish this procedure by checking our answer if we have time, by doing the distribution procedure just to make sure that it produces the original expression. So x times x is x squared, x times 3 is 3x, negative 2 times x, and then negative 6, that's negative 2 times 3. Combine the like terms here, x squared plus x minus 6. Sure enough, that does match the original, and so that means that this is the factored solution, x minus 2 times x plus 3. All right, all I'm going to do for the rest of the video here is show you some additional examples of that. So if you want to give it a shot, pause the video, try it, and then unpause it and see if you got it right. Okay, so to do this one, we would make our t-chart. We're going to have two numbers that multiply and add to something. They're going to multiply to the two outside numbers multiplied, the a times the c. So that's 1 times 10, so positive 10. And they need to add to negative 7. Okay? Now, since they're multiplying to a positive, there's two ways that can happen, right? That can either both be positive or they can both be negative, because a negative times a negative is a positive also. So how many ways can I make a 10 out of two integers by multiplying? Well, I can have 1 times 10 or negative 1 times negative 10. I can also have 2 times 5 or negative 2 times negative 5. And let's add them across the rows to see what they add up to. 1 plus 10 would add up to 11. Negative 1 plus negative 10 is negative 11. 2 plus 5 is 7. Negative 2 plus negative 5 is negative 7. And since I need negative 7, it's the two numbers in the bottom row, negative 2 and negative 5. So I would put my factors together with the x, that's going to make the x squared, and then I'd fill in a negative 2 and a negative 5. And that should be the correct answer. Double checking. X minus 2, x minus 5. Everything on the right multiplied by x first, x squared minus 5x. Everything on the right multiplied by the negative 2, negative 2x plus 10. So that's x squared minus 7x is plus 10 when I combine like terms. And that is the original expression, so that is correctly factored. Okay, another example here. Pause it, try it. Okay, let's see if you got this right. So multiply, add. They're going to multiply to 1 times 9 and add to a negative 6. Ways to get positive 9. 1 times 9, negative 1 times negative 9. 3 times 3, negative 3 times negative 3. If you add, you get 10, negative 10, 6, and negative 6. And since I need negative 6, the two numbers are both negative 3. And that's okay, they could be the same number, x minus 3, x minus 3. But if that's true, there's another way to write that. Whenever you have anything times itself, that's called that thing squared. So this could also be written as x minus 3 squared. Either of those would be a correct way to write it. Let's double check it by taking the multiply out form here. X minus 3 times another x minus 3. Everything in here times x. Everything in there times negative 3. Combine like terms and compare. That looks like that works, so that's the answer. This particular thing right here, where if you get what's called a binomial squared, if that's true, this happens to have a special name. It's called a perfect trinomial. We will investigate that a little further in the completing the square video later. Okay, let's do another example here. X squared plus 7x minus 30. So we could make the table. We're going to multiply 1 times negative 30, add to 7. And since we're multiplying to get a negative, that could be a positive with a negative. Must be a positive with a negative. So we could have 1 times negative 30 or negative 1 times positive 30, 2 times negative 15 or negative 2 times 15, 3 times negative 10 and negative 3 times 10, or 5 times negative 6, negative 5 times 6. Lots of ways. Rather than add them all up, let's just try to zoom in on the one that gives me positive 7. It's going to be this one, right? 10 plus minus 3 is 7. So negative 3 and positive 10 are the numbers. X minus 3, x plus 10. Okay? We could double check that. That would be x squared. Let's see, plus 10x minus 3x minus 30. And then x squared plus 7x minus 30. And that one does work. All right. There's actually another case you can use this in. For some situations, you can use this kind of factoring even when there are two variables, like an x and a y. To see why, let's work something backwards here. What if I had x plus 2y and I had x minus 3y and they were multiplied together? everything in here multiplied by x would be x squared minus 3 times x times y. And then everything in there multiplied by 2y would be an x times a y times a 2, so that's positive 2xy. And then a 2 times a negative 3 is a negative 6, and a y times another y. And then there's a combining like terms here. We would have something like this. So if you have this particular form, where you have something that has something like x squared, and over here something with y squared, and then in the middle it's an x times a y, then you can use the same kind of factoring. Let me show you how. Let's say I had that x squared minus xy minus 6y squared. What you can do at first is ignore the right variable, ignore the y in this case. So I'm going to write it over again. X squared minus x, I'm just to ignore the y, minus 6. And then you could do your normal factoring procedure, MA. We're going to multiply to negative 6 and add to negative 1. So that's 1 times negative 6, negative 1 times 6, or 2 times negative 3, negative 2 times 3. And let's see, that'd be negative 5, 5, negative 1, 1 when I add those. And so I need negative 1 there. Looks like it's 2 and negative 3. And so we would say this is x, and then plus 2, and then x minus 3. Now here's what I'm going to do. Because I ignored the y, what I'm going to do is just reinsert it in the right side of each factor, like that. Because if you do that, you'll see that in fact it does work. Let's take that off on the side and just verify that that does work. You should always check in this case. X times x is x squared. X times negative 3y, 3yx, okay? Plus 2 times x times y minus 6y squared. X squared minus xy minus 6y squared. That did work. So that does work in that case as well. Kind of a special situation. All right, that concludes this video. When you're done, go ahead and try your hand at some of the practice page problems, and when you're ready, check your understanding. And then we'll talk about the case where you have something like 6x squared or negative 2x squared for the beginning of the trinomial in lesson number 3. Thank you.